EER and SEER are metrics that are used. They are a rating system that are commonly used to rate the efficiency of air conditioning systems instead of using the coefficient of performance. So coefficient of performance uses your thermodynamics to accurately calculate a type of a capacity or an efficiency. But EER and SEER are more a commonplace label that is put on the equipment and a way of judging whether a system is more efficient than others that you are comparing it to. So EER is efficiency at a certain sort of test values. So those are defined. Natural Resources Canada has publications of how you test the EER, and it's how efficient it is in those set conditions. That is typically used for window air conditioner systems. So you buy a window air conditioner system and it is rated with an SEER. An EER. SEER is the seasonal energy efficiency rating. It's also a rating system. The SEER is typically used in Canada, governed by Natural Resources Canada. It is used to rate central air conditioning systems and heat pumps. It takes into account, it only looks at the efficiency over, it doesn't look at it at one bit of time with certain test conditions. It looks at it over a range of basically a season, which is a summer. So EER is perfectly acceptable if you are going to be operating at those conditions all the time. So let's say you live closer to the equator, EER, you'll always be performing that way. However, SEER is more realistic in a seasonal environment like what we have in Ontario. You have to keep in mind that these are both rating systems. They are not a math equation per se. They are rating systems that are defined and invented literally to have imperial units of BTUs on top and energy watt or kilowatt hours on the bottom. The more you look into SEER and EER, you'll notice that sometimes it's called BTU per hour on the top and watts in the bottom. So it can be looked at that way. You can see that the units will work out with BTU per hour over watts, electrical power in watts, and that's a handy way to practically calculate it. Another way to think about it is that it is the BTUs over watt hours. So let's do an example. Find the annual cost of electric power consumed by a 72,000 BTU per hour air conditioning unit. It's going to operate for 1,000 hours a year, and it has a SEER rating of 10, which is actually a pretty low rating, and low is not good. You want to be around like 13 range, and that's covered by the Energy Star ratings in Ontario. And the power cost is only 8 cents, so that's a pretty good deal. So let's look at what 72,000 BTUs per hour. If it makes 72,000 BTUs per hour, what this is this is a size. This is a size of an air conditioning unit. And this is how long we're going to run it, 1,000 hours. We have a rating of 10. Notice the units aren't even specified here. Normally, SEER and EER are kind of ratings that are used in industry, and they're not really like a technical engineering term, and they're not even usually expressed with any units at all when you're using them or referring to them. And here's the power cost, dollars per kilowatt hour. And I'm asking for the annual cost of electric power from this unit. So let's start with what we know, our definition of SEER. So SEER is BTUs over watt hours of energy, or it's BTU per hour size over the power in watts. And since we have the size of the system in BTUs per hour, I'm going to use that version of the equation. So I'm going to write it down here just to make it extra clear that I'm going size in BTUs per hour. That's how many BTUs per hour this system can crank out, and that's a common way of measuring. Now, we like to use metric in this course, and we are going to use metric for the whole course, but I want to stress the fact that SEER and EER is a made-up metric system, or a made-up rating system that literally is chosen to be BTUs over watt hours. And we have the power in watts, so I'm going to take the equation in this form. And to figure out the cost of the power for a year, I should solve for power, because I know SEER equals 10 and size equals 72,000. So I can solve for power. And that's going to be size over SEER, right? So 72,000 BTUs per hour over 10. 7,200 watts. Okay, so because of the SEER, the size of this unit, 72,000 BTU per hour unit, is going to take 7,200 watts of power to be able to perform at that size or that capacity. Now it's just a matter of sort of an accounting problem. So we can say accountants. Now we just have to do the counting. We want cost in dollars per year. And we have power in watts. And we also know the utility, I'll just say utility, is, we know that in dollars per kilowatt hours, but we want watts, so we need to get rid of our kilowatts for some watts. So 1,000 watts in a kilowatt, and then we want to get rid of our hours, don't we? And we want years, and we specified in the problem that it's going to run 1,000 hours in 1 year. So automatically your thousands cross out. So let's substitute in 7,200 watts times 0.08 dollars per kilowatt hour. I'll just carry through my unit conversions here for clarity. And then we can cross out our units. Leaving us dollars per year. And how much is that? That is $576 per year. So this is a rating system. It's very commonly used. It's on the Energy Star sticker, and it should be sort of one of the metrics that you use to purchase a system, an air conditioning system in Ontario. And the Energy Star standards do change over time, but they are governed by Natural Resources Canada. And you can see that there is some functionality in this equation where you can use it to do some calculations.